This is section 5.8, Subtracting Polynomials, page 238, number 1 through 42 odd. You'll be doing the green book. Some new vocabulary or kind of old vocabulary that we're going to need is the word polynomial. That means a term that is an expression with multiple terms. And additive inverse, adding the opposite. All right, so today we're working on subtracting polynomials and finding the additive inverses. So an additive inverse is like just adding the opposite. You see the words inverse means opposite, add. It's additive. So what would be the opposite, the additive inverse of y? Basically, we just take the opposite sign, okay? And the additive inverse of a binomial, we're going to use that negative times the whole thing. So that would be negative x minus 3. We take the negative times the quantity of x plus 3, and that simplifies to negative x minus 3. Now I'd like you to pause the recording and do 3 through 6. Now check your work. Negative t, negative times t is negative t, and negative times negative 4 is positive 4. We're taking the opposite of all signs. When I look for the additive inverse, we're looking for the opposite of all terms. The additive inverse would be negative 3m squared times negative 6. So it would end up being negative 3m squared plus 6. Negative times 3 minus w, what it does is, let's look. When I multiply both by a negative, it makes both signs opposite. And notice what I can do. W minus 3. This is going to be important later. So we always kind of want to start with a positive term. And so we would use something like that. And we want to start with a positive term. We just flip-flop them because this one becomes negative, this becomes positive, and I just write the w first and the negative 3 second. All right? The next one would be x squared, the quantity of negative 1 times the quantity of x squared plus 5x. So it would be negative x squared minus 5x. All right, so opposite of a polynomial. So basically, we're just taking the opposite sign of everything that is inside the polynomial. If they're all positive, then they'd all end up being negative. Okay? So for the next one, number 1, we're going to do negative 1 times x to the third becomes negative x to the third. Negative 1 times positive x, 4x, makes negative 4x. And negative 1 times negative 9 makes positive 9. Pause the recording and you try the next 3. Now check your work. So we get negative y to the 5th, positive 2y to the third, and negative 7y. Taking the opposite of all signs. On number 3, it's negative t to the 4th, negative t to the third, plus 9t plus 2. The last one will be negative 5y cubed plus 8y squared, because a negative times a negative makes a positive, and negative 9y and positive 3. Okay, so now we've taken the additive inverse of a polynomial. So basically, when we subtract polynomials, we're doing the same thing. But the first step we're going to take is we are going to distribute that negative and take the opposite of the second polynomial. Because this is saying 8x squared minus 5, the quantity, minus the whole second quantity. So we have to distribute that negative. And so it becomes, I'm going to write down my 8x squared, and it's going to be 8x squared minus 5 minus 2x squared minus 4. And then if I can combine like terms, remember we go in order of the exponents. So I'm going to take my large exponents, x squared, 8x squared minus 2x squared makes 6x squared. And then we're going to take our constant terms, -5 and -4 make -9, and that is my simplified answer. And we are done. There's nothing else we can do. We're not going to get it to equal a number. Okay? This is just simplifying the polynomial. I'm taking one polynomial, I'm subtracting the other. And we simplify it as much as possible. Pause the recording and try the next one on your own. Now check your work. Oops, I don't know what happened here. Okay, now check your work. Of course, it's not working now. Pause the recording. Okay, there we go. Finally got it fixed. So I'm going to be distributing the negative to the 4k squared, and negative times negative 2k makes positive 2k. And I write all the other terms down, and then I combine my like terms. I've got negative 6k squared, and I'm doing this one, and that makes negative 10k squared, and then we've got negative 3k plus 2k makes positive k. And then I've used everything. I've got my plus 1, the constant. Okay? Next one, we're going to distribute first that negative in the middle. It becomes negative 2t squared, negative 5t, and plus 6. And then I combine my like terms. We get 6t squared minus 5t plus 13. All right, just doing a little bit more. Try the next two. Now check your work. Number 4. Number 4 is negative 11x squared minus 10x plus 3. Number 5 is 2t squared plus t minus 17. Okay, subtracting polynomials in word problems. Mark owes his friends $50. Mark has $50 and owes his friend some money. He owes Jim $12, owes Carol $6, and owes Steve $10. So we can write this, since I can do 50 minus all of those quantities and distribute it in. Or I can do 50 minus 12 minus 6 minus 10. So it's just like subtracting a polynomial. Two ways to look at this. All right, let's move on and look at another word problem. I think we can skip these. These are just using trinomials. Remember, a trinomial has 3 terms. It's more distributing and then combining the like terms. There's more of the same here. If you want to work on these, you can pause the recording, and I will put the answers up. Oops. More of the same. Now we're mixing it up. Check your work. Now we're mixing it up. The only difference is, remember when I have that plus sign here, when I distribute a plus sign, it's still going to be 9x squared. It's still going to be plus positive times a positive is still positive, and a positive times negative still makes it. It's going to be the same. So you will likely have these mixed together. Okay. All right, next, just some more. I think you guys have had enough practice. You can start with the homework. Oh, let's talk about degree. Okay, so simplify the expression below and state the degree of the result. So the degree of the polynomial, I think we explained this before, is the degree of the polynomial is the highest exponent. So in this case, it's a 2, so this would be a second degree polynomial. Once I simplify here, and we add them together, since my exponent is 4, right here, since it's a 4, it is going to be a 4th degree polynomial. All right, so let's do some word problems. Write the expression that represents the area of the shaded region. So basically, if we're looking for area, they mention the word area, the formula is area equals length times width. So if I'm taking, we always go with kind of like the bigger square. Really, the area is going to be equal to the big square minus the area of the small square, right? So the big square is 9 times 3x plus 7 minus the area and length and width. Really, you're doing length and width. So this would be, I should say, length, oops. This is length times width and length times width. So for the small square, I'm doing 5 times x plus 2. And we can simplify that. A equals 9 times 3x is 27x plus 63, sorry, minus 5x minus 10. Combine our like terms and I get the area is equal to 27 minus 5 is 22x plus 53. Okay. Now in the next one, I'm going to just show you. So we're taking the big one. The only difference they're doing is they didn't write area equals. Now, in this case, we're going to take, same thing, the big rectangle area, which would be, why don't you pause it and try the next one on your own. Now check your work. We do big rectangle, length times width, minus the small rectangle, which was 3 times the quantity of x squared minus 8. Now that minus goes right before all of the second rectangle. And so I distribute, and we combine like terms. Oops. Sorry about that. And we get 13x squared plus 56. All right. Find the length of BC in terms of x. Okay. So really this is about creating an equation. We know the whole part. From A to C, we know it's equal to x squared minus 3x. So I know the whole. So let's say I had something like this whole thing is 5, and this is 3 and 2. If I wanted to get this missing measurement right here, we don't know how much it is, wouldn't I take the whole and subtract the part? Right? 5 minus 3, and we get the other missing part. Well, we're going to do the same thing here. We're going to take the whole, which is AC, that whole thing, AC, which is x squared minus 3x, and we are going to subtract the part, which would be, sorry, it's such a mess here, the part AB, which is right here. We're going to subtract that, which is this, minus 3x squared minus 5x plus 4. And I'm lining it up. I'm lining it up. So first thing we have to do is distribute that negative. So this becomes a negative, this becomes a positive, and this becomes a negative. And then we just combine our like terms. I've got negative 4. I have plus 2x. And here we have minus 2x squared is our final answer. So we're taking the whole minus the part gives us the other part. Pause the recording and try number 2. Now check your work. Okay, so I'm doing AC minus x squared minus 5 plus 5x, but we have to subtract the whole thing, minus 1. We distribute that negative, and then we get, remember, that negative makes this positive, this negative, and this positive. And we end up with negative 6x squared minus 15x plus 8. We can try one more. This looks kind of tricky, but it's really not, because they give us, find the area of LMP. Okay, that's LMP. Triangle LMP is in here where the yellow is. So we do know if the area of rectangle LMNO, we know the whole thing is, the whole rectangle LMNO is 10x squared plus 18x. So half of that, right, would be this. It would be, if I divide all terms by 2, I end up with 5x squared plus 9x minus 2. With me? So if I just divide it, because all we're really talking about, we've got information for half of it. Okay? So half of the entire rectangle equals this. And now we can subtract the one part, 6x squared, and then we end up with the missing part. 6x squared minus 5, line it up, and we end up with, before you, don't forget to distribute, you get a negative and a positive, and that's why we end up with negative x squared plus 9x plus 3. And that, my friends, I believe is it. Let's check one more. That's it.